Hello student, today we are going to learn what is Bernoulli's theorem and also we are going to learn how to derive this equation and we are going to learn what is this equation saying, okay. So in this equation, P is the pressure, rho is the density, G is the gravity, H is the height, V is the velocity. We are going to prove this equation is a constant. Bernoulli's theorem is saying total energy is a constant. That only we are going to learn how to derive this equation. So I am taken as a special tube, okay. From the ground it is h1 height, this A end will be h1 height, B end will be h2 height, okay. So two places, where will be the potential energy is greater, A or B, A point or B point. In B point potential energy is greater because there is more height, the energy will be greater. So B point potential energy will be greater. So just for an idea only, okay. The liquid is flowing from this end to this end, V1 velocity, V2 velocity, where the velocity will be greater, okay. The volume of the liquid flowing per unit time is constant. That means, so it is a big area, area 1 and a small velocity, area V1 velocity, and it's a small area, area 2, V2 velocity, okay. V2 velocity will be greater. I can give one example. When you are closing the tap, the velocity will be getting increased, okay. So this is called equation of continuity. That also we are going to learn. Total volume of the liquid flowing per unit time is constant, okay. That also we are going to see in this particular video, okay. So this what we are going to learn. Height 1, height 2, V1 velocity, A1 area, V2 velocity, A2 area, okay. Now we will see what we are going to learn. The total volume of the liquid flowing per unit time is constant. Volume of the liquid at A side is equal to volume of the liquid at B side, okay. Now volume is going to be area into length, area into length. It is going to be A1 area and it is going to be A2 area. So length, how much liquid is flowing per unit time, so divided by time, length per time, it's going to be velocity. A1 V1 is equal to A2 V2. It's an equation of continuity, okay. In case if you are taken third point, A3 V3, fourth point A4 V4, like that will go. It is called equation of continuity, okay. Now I am going to start the equation. Bernoulli's theorem, total energy is a constant. How it's going to be? Total energy is a constant. First one, I am going to calculate what is the work done here, okay. Work done by the liquid at the point of A. Work done, usually we will take it as a force into displacement, but here I am taken pressure into changing volume. Because of the liquid, I am taken pressure into changing volume. How come force into displacement is the pressure into volume? Pressure is equal to force per unit area, volume is the area into length, both is same. So pressure 1 and changing volume, it's for at A side, okay. Same thing work done at B side, okay, this end, okay. So it's going to be pressure 2 dV, because pressure at this point I am taken as a P2, pressure at this point I am taken as a P1. So what is the pressure difference? So work done between A and B, total net work done A and B, it's going to be where will be the pressure more, where in depth pressure is the more, okay. So here only pressure is the more. So P1 is greater than P2. So P1 minus P2 dV. You can have this question, why P1 minus P2? Because P1 pressure is greater than P2 pressure, because in depth the pressure will be more. I have the equation 1. It's going to be represented as the net work done. The next thing, equation 2. So potential energy formula already we know, mgh. So potential energy at A, potential energy at the point of A, at the point here, height 1, so potential energy mgh, kinetic energy of mv square. So it's going to be height 1. Why? Mass of the liquid entering per unit time is constant. It is because of equation of continuity, mass of the liquid is going to be constant. No need to show us the gravity difference, okay. So same potential energy at B point, the another end, this point, okay. It's going to be m times of GH2. Changing potential energy. changing potential energy. So mg h2 minus mg h1. Maybe you can have one question, sir, here P1 minus P2 you wrote, here h2 minus h1 why you are writing? Because this is greater potential energy, okay. So P2 is greater than P1, sorry, potential energy 2 is greater than potential energy of 1. So potential energy here will be the greater, at height the potential energy is greater. Example, in water tank you kept on the top of the building because it will create more potential energy. So common I am taken outside, h2 minus h1 is going to be changing potential energy. The next one, what is the kinetic energy? Kinetic energy at the point of A, at A is going to be of m v square, v1 square. Kinetic energy at the point of B, it's same of m v2 square. Okay, the next thing, which is greater kinetic energy, A or B? B is going to be the kinetic energy will be great, because less area more velocity, more area less velocity. So B kinetic energy will be greater. So changing kinetic energy is equal to of m v2 square minus of m v1 square. Now it is equation 3. Kinetic energy is equation number 3. Potential energy is equation number 2. Okay, work done is equation number 1. So we have 3 equations. Now I am going to write it. What is changing work done is equal to potential energy plus kinetic energy, total energy. Okay, changing work done is equal to total energy. Changing work done equation 1, potential energy equation 2, kinetic energy equation 3. Just that only I am going to substitute here. It's going to be P1 minus P2 dV is equal to mg h2 minus h1 plus of m v2 square minus v1 square. Like that I substitute all 3 equations, I will get like this equation. Okay, now density is equal to mass per unit volume. So volume is equal to mass divided by density. Very simple. So I am going to substitute in the above equation. So density is equal to mass per unit volume. Okay, mass is density, sorry, density is equal to mass per unit volume, volume is equal to mass by density. So pressure 1 minus pressure 2 into mass divided by density is equal to y sir dv. dv is representing small volume, so no need to represent. M g h2 minus h1 plus of m v2 square minus v1 square. This like this will get whole equation divided by m, whole equation divided by m divided by mass. So P1 minus P2 divided by rho is equal to mg h2 minus h1 plus of m v2 square minus of m v1 square. Just this I am taken as a common inside. Okay, so this density also is for both the term, it is for both the term. Now see here I am writing separately. So it is going to be P1 divided by rho minus P2 divided by rho is equal to mg h2 minus mg h1 plus of m v1 square v2 square minus of m v1 square. This and this, if you are taken left side, minus sign is going to become as a plus. This if you are bringing as a right side, minus sign is going to become as a plus. So P1 divided by rho plus mg h1, because mass total equation you can divide with the mass. So mass won't be there, mass won't be there, mass won't be there. So mass won't be there, mass won't be there, mass won't be there, mass won't be there, mass won't be there. Okay, so P1 by rho plus g h1 plus so of v1 square. P2 divided by rho plus g h2 plus of v2 square. So this is going to be constant. P1 divided by rho, work done, and potential energy plus kinetic energy is going to be constant. This is what we learned from the Bernoulli's theorem. Thank you for watching my video. If you like my channel, please subscribe. Thank you so much.